Good afternoon. We're going to start the presentation in just about a minute. Okay, good afternoon, and thank you for joining us on our call today. My name is Nicole Van Wert-Quincy from Transcat, and I will be your moderator this afternoon. Our webinar topic is Calibrating HART Smart Pressure Transmitters. The topic is being presented by Bob Krebs from Fluke. Bob is the Fluke Process Tools Product Specialist, providing engineering-level support and technical product training worldwide. He has over 30 years' experience providing technical support and training for computer printers, fiber channel switches, and for the last 6 years in process calibration tools. We expect the presentation today to last roughly 30 minutes, and then we'll answer any questions that have been submitted. During any time of the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention that the webinar is being recorded. You will each receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. And at this time, I'm going to turn the presentation over to Bob.
Hey, thanks, Nicole. Thanks for having me today, and welcome everybody. As the Process Tools Product Specialist, I get a lot of calls about pressure calibration, and I thought today I'd share with you some of my experiences and talk about different types of pressure calibration. So, 4 main topics I'd like to talk about today. First, just a quick discussion of HART. What is it? Second, go through calibrating a HART pressure transmitter using a documenting calibrator and a handheld pump. Third, we'll go through calibrating the HART pressure transmitter using an automatic documenting pressure calibrator. And finally, I'll go over documenting calibration software and how it works with the pressure calibrations. So HART, what is it? Well, it stands for Highway Addressable Remote Transducer, which has all kinds of ideas running in the head, but basically what it is, it's a digital protocol which allows you to communicate with the transmitter through the 4020 milliamp line. It's used widely in process nowadays, and many companies are as they replace the old analog transmitters, they'll put in a HART transmitter. So that's why HART's important, and it's good to know how to do a calibration using HART. The HART Foundation is a nonprofit organization that supports HART technology. Fluke's a member of it. Many of the transmitter companies are, and that's where all those device descriptions go for calibration. So let's look at some of the reasons why HART is used. Okay, first off, it allows you to simultaneously do your 4020 milliamp measurements and talk digitally HART across the same wiring. So you don't have to change the wires that you're using, use the same cabling, makes all that information easy to get at. You can also not just do calibrations, but you can also check out the tag ID numbers, your measured values, ranges, and of course, all kinds of commissioning information required for a transmitter. So all this, helps reduce operation costs and makes life a lot easier having those smart instruments out there. So let's take a look at doing a calibration using a HART pressure transmitter and connecting up using a documenting calibrator and a hand pump. So first you have to, you need something to apply pressure control to the device under test. A couple different options are using hand pumps, which can be pneumatic. Many of them go up to about 600 PSI. Some can also give you vacuum to do vacuum pressure calibrations. For higher end pressure, you may need to go to a hydraulic pump, and that's the one you see on the bottom right. And that would use something like mineral oil or distilled water, and that will get you up to about 10,000 psi. Lastly, some of the guys out there will carry on a nitrogen bottle and with the regulator. So that that's a challenging. You've got a heavy bottle you carry around. You got to, it's got a regulator on it so you can, mitigate small leaks. But if you're using it for high pressure, sometimes you're going to have to replace it with another bottle or refill it, that sort of thing. So those are the pressure sources that the techs are going to be using out in the field. So let's take a look at how a connection is going to look like. So here's a simplistic version where you've got your calibrator on the left. In this case, we got a Fluke 754, and you got your red and black wiring down here, going straight up to the transmitter to power it, to measure your 4 to 20, and to talk HART through this line. Then you're going to have a couple different options. In this case, we're hooking up a pressure module, and we've connected it right up to the pump, so it's just a straight shot. But in many cases, you're going to have the pressure module hanging separately close to the transmitter, and in that case, you're going to have another pressure line going to the pump. So it's going to, you may have like a T involved, and more pressure lines you have to deal with, and of course, pressure lines. There's always chances of leaks. You always have to get your thread seal tape on there and make sure you got a good connection. From that point, now you've got your pressure source. You can pump up to the different pressure values, measure your 4 to 20 output, and verify your calibrations in spec. So the next thing you want to do is you want to connect HART communication to your transmitter. So in this case, we've taken our calibrator, connected it up, and you'll see you're going to get things like, your tag ID name, your PV values, your upper or low range. This information is automatically available through HART. So once you connect up, that information's available instantly for you. From that point, now you want to configure how you're going to measure and source. In this case, you'd be sourcing your pressure and measuring your milliamp value. Finally, you want to define how you're going to do the test. In this case, we're going to set up our tolerance, and that's the accuracy required by the customer, and that's of course determined by what your company requires for your standards. And then lastly, you've got your 0 to 100% values, which are automatically read by HART, but you want to put in what kind of test strategy you want to do in the calibration. For example, in this case, it's set for a 3-up, so you'd go 0, 50%, 100% of that 0 to 5 psi. Once you have all the configuration information set up, it's now time to perform the actual calibration. So with your hand pump, what you're going to do is go through that 3-up test. You'll start out, with open pressure at 0 psi. You'll record that milliamp value and accept it. Then what you'll do is you'll move up to the next value. So you'll pressure up to, in this case, 2.5 psi. Pump the pressure up, fine tune it, get it in, and hit accept. And then finally go to the 5 psi mark, the 100% value. Bring the pressure up, make sure it stays steady, and then accept that value. Once those calibration points are taken, you'll then, since you're using a documenting calibrator, you've got your tag ID name and your serial number, which are automatically put in because HART has captured that information off the transmitter. Put in the name of the person that's doing the calibration, and you've completed the as found. So at this point, if it's in spec, if everything was in spec, then you finished your calibration and you go on to your next transmitter. But if it's out of spec, now you're going to have to do some adjustments. With HART, you do this, you can do the trim for your input sensor and your output milliamp. You can do that digitally with the HART. If you had an analog transmitter, of course, you'd have your 0-100% span adjustments you'd be doing with a screwdriver, but this is a lot more accurate. So with the calibrator, you can go in and do your output trim for 40-20, verify, what the transmitter thinks it's putting out. Here's the PVAO it thinks it's putting out 4, but this 4 in this case is measuring 4.1, so it's out of spec. So what you do is you fetch that value and you trim it so that it brings that back into that 4 milliamp specification. And then you'd go ahead and repeat that for the high end on the 20 milliamp. So now you've finished your 4-20 milliamp output trim. Second, you want to go ahead and do your sensor trim. So with the 754, you can trim both your upper and lower values. So you go in and put in the 0 open to atmosphere pressure at 0, trim it so that it matches up, and then you'd pump the pressure up to the upper end, which in this case was 5 psi, pump the pressure up to 5, and trim it to that. So that now you've got your sensor trim adjusted and your 4-20 trim adjusted. Once you've finished making your digital adjustments through HART, now you can go ahead and repeat that test that you did to start for the as found, but now it's going to be the as left test. So this is the final test. Go ahead and do that, the same calibration procedure we talked about before. In this case, hopefully you've done your trim adjustments correctly and you've got your results are within spec. You would then, again, document those test results. For that, so you've got your as found and your as left results. Now you've finished your calibration. This information is documented and saved in the calibrator, and we'll talk about what we're going to do with that with the software in a few steps. Okay, so that's how you do it with a hand pump. Now let's talk about calibrating a HART pressure transmitter using a documenting automatic pressure calibrator. So some key advantages having an automatic pressure generating system. It's easy to use, obviously. It's got a built-in pump and a pressure regulator. In this case, with the Fluke 729, goes up to 300 psi. It's got built-in leak detection for verifying setups before you even start your calibration. And basically what it does is solve a big pressure pain point that I get calls on this all the time, and that's having to do a manual pressure generation to do a calibration. So here's your typical connection. Okay, that little silver looking thing on the side there, that's actually a mounted pressure transmitter. It doesn't have all that fancy blue casing for outdoors. This is more of a lab type setup transmitter, nice and small. But you can see, I've got my wiring from the calibrator going to the transmitter, and just one line going from the pressure sensor in the transmitter right to the pressure port of the calibrator. So just having a single line makes it a lot easier. Less chance of pressure leaks, and of course, with that calibrator, we've got the built-in pressure regulator and pump. So configuring is going to be pretty much the same as doing the configuration on a calibrator with the hand pump. It's going to automatically give you that information. What your source pressure needs to be, what your 40-20 output is. And again, if it's a downloaded task from software, you're going to have things like your tolerance already built in and the test strategy built in. So if not, if you're doing a manual test, then you'll need to plug those values in. And we go through the same process as we did with the hand pump calibration. The key difference is when you go to do that as found test, remember when we talked about using a hand pump, you have to go to each pressure point and stop, settle it, get that reading, and then press, press accept to get that pressure point. Well, with the automatic pressure calibrator, you basically just press start. Just do auto test, and the calibrator, in this case, the 729, will apply pressure to each test point. In this case, it was a 3 up down test. So it goes up to each pressure point, stops, stays there for a period of time, captures that information when it's stable, then automatically goes to the next test point. So it does all the work for you. It really makes your life a lot easier. And for those that have difficulty using the hand pump or they haven't done it for very long, this makes the job real simple and quick. Again, if it's out of adjustment, you need to do your HART trim and then repeat your as left to get those results. And again, it has that same auto test feature, so you don't have to do any hand pumping. Really increases the how quick that process is done and decreases the time spent. So again, when you finish your calibration, all this information is also documented. So let's take a look at what we can accomplish using those documented calibrators. For one, when you go out in the field and you've got a piece of paper and a pencil, you've got to write down all those measurements, all the results. You got to figure out if it's in spec or not. You don't have to do that with a documented calibrator. It electronically captures all that information and lets you know if it's in spec or not. It eliminates having transcription errors. I don't know about you guys, but my handwriting's not so good. And if I was to give that calibrator and my test report, back to the administrator, they'd have to read my writing. So that makes it difficult. So yeah, you don't have to manually enter that data into a PC because it automatically uploads. So pairing a documented calibrator with management software, optimizes your time, and it allows auditors to have that information available, to look at those test results. It's all documented for you. So let's take a look at some of the benefits of having that software. Okay, for one, once you have your instruments loaded into your software, now you can select which task you want the technician to perform. So let's say you want technician Bob to go out to a boiler and calibrate 5 transmitters out there. Well, you can select those transmitters and download that information. And all that information is built in to the task. So those templates can be downloaded quickly to the calibrator, and then once those calibration results are done, then you can upload those test results and they'll get populated into the database, easily accessed by whoever's using the software. Here's an example of a test report. Now this was printed out using Fluke's DPC Track 2 software. You can see in that report you have your company information up on top, the instrument ID, when the calibration was done, information about the device, but more importantly, inside the box, this big box here, this is where those calibration results are stored. And this is what the auditor looks at. So you have information, you've got your as found, as left results, whether or not the calibration was in specification, and whether it passed or failed. And then another important thing is the auditor is also going to want to know, well, what about the instrument, the test instrument you use to do the calibration? Well, that information also can be stored in the software. So in this case, I use a Fluke 729 to do the calibration, and you can see, at the time the calibration was done, it was within specification and in tolerance. So that's the kind of thing that auditors look at, and this is all protected. You can save the information as PDF files in your database. You can print reports out in multiple formats and access that information as needed. That is pretty much how those different calibrations are done with both a hand pump and with an automatic pressure calibrator. And that's, I'll leave it back to you, Nicole.
All right. Thank you. So this concludes our presentation portion of the webinar. We'll now move into the question and answer session. And as a reminder, if you'd like to ask a question, you can send it through the question box in your webinar controls, which is on the right side. Let me see what I have here. Okay, first one, do you have any videos that demonstrate pressure calibrations?
Yes, we do actually. There are videos for both the 754 and for the 729. Those they're up on the Fluke website. You can also just search on 754 or 729 or even DPC Track 2 up on YouTube. All that information is available.
Okay, I've got to check our website. We probably have some videos as well on the 754 and 729 pages.
Oh, I think you do.
Yeah, we probably do. What kind of hoses and fittings should be used for pressure calibration?
Well, there's a lot of options out there. We have, you saw in the video, we had the plastic hose on the 729. That pressure is good up to 300 psi. But if you want to go higher or have something that's more secure, we have hose kits, 700 TTH hose kits that go up to 5,000 psi and up to 10,000 psi, and they have really cool fittings on there that allow you to not have to use any tools. No thread seal tape. You can actually screw the IEC connectors right into the side of a transmitter. That makes it really fast to change out and do calibrations.
Okay, the next one is more of a statement than a question, but maybe you can comment on this. He says, I have trouble with wet calibrations on transmitters used on water.
Oh, yeah, and with the liquid calibration, you have a couple options. If you want to use air, you need to isolate the transmitter from the line that's coming in. I've heard of guys using air to blow up the sensor hole to the transmitter, and then connect up the pressure calibrator. The other thing is for pumps like in the 729, we do have a liquid dirt trap that you can mount on there that prevents small drops of fluid from getting into the calibrator. The other option is using the hydraulic pump, and that's where you can use distilled water with it to do your calibration, or in some cases, if you have hydraulic fluid, you need to use that. That's where you can use either hydraulic fluid or mineral oil.
Okay. How many test results can be saved on a documenting calibrator?
Oh, it's a good question. Conservatively, you can put at least 50 on there. I've had cases where it's gone a lot higher, but I would recommend that you always clear out the calibrator after every shift. So, if you've got a tech doing, let's say, between 5 and 10 calibrations, I'd recommend, go out, do your calibrations, bring them back, upload those test results, and then so there's no confusion on what's been done before, after, go ahead and delete those results for the next shift. That's probably the best way I would recommend doing it.
Okay. And software packages. What software packages support the documenting calibrators that you feature?
Well, for the Fluke stuff, for the 729 and the 754, we do have the single PC DPC Track 2 software. If you want to go to more of an enterprise system where you have multiple PCs accessing and sharing the same software, Prime Technologies has a great software package called ProCal V5.
Okay. All right. One more. Is there training available for the software?
Yeah, if call me, I can do a 1-hour training class for customers. If you buy the software and you're having difficulties, watch the videos first. But if you have questions, or I with a lot of customers, I've spent an hour, just doing a WebEx like what we're doing today, and I'll go through the software. I just did one for a company this morning actually, and got them going. So yeah, I'd be happy to help. Just get a hold of Nicole there, and you can get to me if you need to, and I can help you out for sure.
Thanks, Bob. Okay, that's it for questions. So that concludes our time for today. If you have any further questions that weren't answered, or you'd like to find out more about Transcat's products and service offerings, you can contact us at 800-800-5001, on the web at transcat.com, or you can email me directly at nvanwert@transcat.com. It's on the last slide. Thank you all for joining us today. We hope you got something out of the presentation and that you continue to join us for future Transcat e-learning webinars. Thanks, Bob.
Thanks, Nicole. Talk to you soon.
All right, take care.